Welcome back to AI Research Weekly, the show that cuts through the noise to bring you the most critical advancements in artificial intelligence. I'm Nova.
And I'm Onyx. This week, we saw a clear thematic signal across hundreds of papers: the relentless push for robust, reliable, and ethically governed multi-agent AI systems. It's less about raw model capability now, and more about how these agents interact, manage context, and perform dependably in complex, often adversarial, real-world environments.
Absolutely, Onyx. The field is clearly maturing beyond just scaling LLMs. We're seeing a deep dive into the engineering and architectural challenges of making these intelligent components actually work together, and crucially, making them trustworthy. From managing context in long-horizon GUI tasks to ensuring ethical coordination, the focus is on stability and safety.
Precisely. Today, we'll be dissecting several key papers that exemplify this trend, along with a look at the week's most significant industry moves. So let's jump right in.
Let's start with a paper that tackles a really thorny problem for agentic AI. Agent Prog, empowering long-horizon GUI agents with program-guided context management. Anyone who's tried to build a sophisticated GUI agent knows that context management is a nightmare. As tasks get longer, agents forget what they're doing, or the prompt context just explodes.
That's a classic problem. Traditional GUI agents often suffer catastrophic degradation on long-horizon tasks because they can't effectively retain and manage interaction history. This paper, Agent Prog, proposes a novel solution, reframing that interaction history as a program.
Right. The key contribution here is their program-guided context management. Instead of just appending observations to a long list, Agent Prog distills the interaction history into a structured program. This allows for principled information retention and discard. They also integrate a global belief state mechanism, inspired by belief MDPs, to handle partial observability and environmental changes.
It's a smart architectural choice. By representing the interaction as a program, they introduce a hierarchical structure that naturally enables abstracting away low-level details while retaining high-level intent and progress. This dramatically reduces the context overhead, which is a major bottleneck for LLM-powered agents.
And the results are compelling. Agent Prog significantly improves success rates on long-horizon GUI tasks, outperforming baselines that, as you mentioned, just catastrophically degrade. They achieve state-of-the-art results on Android World and an extended long-horizon task suite. While they don't give exact percentages for all tasks, the qualitative description implies a significant jump from baseline failures.
What's particularly noteworthy is how this tackles the brittleness problem we see with many agents. By maintaining a global belief state and a program representation, the agent gains a more robust understanding of its current position and objectives, making it less susceptible to minor UI changes or unexpected interactions. It's a foundational step towards more resilient GUI automation.
But what are the limitations, Onyx? Is there a ceiling to how complex these programs can get before the LLM struggles to generate or interpret them effectively? And what about dynamic UIs, where the program structure itself might need to adapt?
That's a valid concern, Nova. The effectiveness of the program-guided context management likely depends on the agent's ability to accurately infer and refine these programs. Highly dynamic UIs or extremely ambiguous task specifications could still pose a challenge, requiring more sophisticated program synthesis capabilities from the underlying LLM. However, it's a significant leap beyond simple context window stuffing.
From managing context, let's pivot to auditing robustness in a related domain. Mobile GUI agents under real-world threats, are we there yet? This paper throws a cold dose of reality on the deployment readiness of these agents.
While Agent Prog focuses on improving inherent capabilities, this paper focuses on validating those capabilities under realistic, often adversarial conditions. Their core finding is stark. Existing mobile GUI agents, even those with high benchmark accuracy, show significant performance degradation when faced with untrustworthy third-party content.
Significant degradation is an understatement. They found an average misleading rate of 42.0% in dynamic environments and 36.1% in static environments for all examined GUI agents, both open source and commercial. That's almost half the time, these agents are being led astray by deceptive UI elements.
This highlights a critical pre-deployment validation gap. Standard benchmarks often don't account for the impact of untrustworthy app content, which is a common occurrence in real mobile ecosystems. They introduced a novel scalable app content instrumentation framework to flexibly modify existing apps and simulate these threats, which is a valuable methodological contribution in itself.
So, even with advanced context management like Agent Prog, if the agent can't discern malicious or misleading UI elements, it's still highly vulnerable. This suggests a need for a much stronger safety layer, potentially a dedicated perception or trust module that operates before the core task execution logic. What's the so what for researchers here, beyond our agents are brittle?
The so what is twofold. First, we need to drastically rethink our evaluation paradigms for agentic AI, particularly for GUI interaction. Traditional benchmarks are insufficient. This paper provides a new test suite, a dynamic task execution environment with 122 reproducible tasks and a static dataset of over 3,000 challenging GUI scenarios, which can serve as a foundation for more rigorous testing. Second, it calls for dedicated research into robust perception and adversarial robustness for GUI agents, potentially incorporating techniques like content verification or anomaly detection at the UI element level.
It sounds like the real world is always more complex than our simulated environments. This brings us to another paper addressing real-world reliability, but from an ethical perspective: ethical coordination of LLM multi-agent systems. This directly tackles the governance challenge in multi-agent setups.
This is a crucial piece of the puzzle for truly deploying complex AI systems. The paper introduces a constitutional governance layer designed to maintain ethical cooperation in LLM multi-agent systems. Their central finding is that this layer successfully maintains an ethical cooperation score, or ECS, of 0.176. Crucially, this significantly outperforms an unconstrained baseline, which collapses to an ECS of 0.
An ECS of 0.176, how do we interpret that? Is that a good score or just better than 0? It feels like we're still in the early stages of quantifying ethical behavior in a way that gives us confidence.
That's a fair challenge, Nova. While the exact numerical value might seem modest, the fact that they can establish a non-zero stable ethical floor is a significant methodological advance. The paper emphasizes the autonomy paradox. Unconstrained agents might resist manipulation more forcefully. They cite 0.856 versus 0.728 in resistance, but this often leads to a collapse of system-level integrity, an ECS of 0. This demonstrates that individual agent-level defenses aren't enough. Systemic governance is required.
So, giving individual agents more willpower might make them harder to manipulate individually, but it doesn't guarantee the overall system acts ethically or coherently. That's a powerful insight. And the efficiency is impressive. Their proposed filter runs at 0.78 microseconds per call, enabling always-on deployment in adversarially contested electronic systems. That's 1.3 million decisions per second per core.
The efficiency is critical for real-time application in high-stakes environments. They also show strong robustness. The constitutional layer is monotonic in resistance, seed-stable, topology and backbone invariant across 5 contemporary LLMs, and robust to alternative ECS formulations. This suggests a generalizable and reliable mechanism. It also matches the integrity floor of constitutional AI critique revise and LlamaGuard-style safety classifier baselines, while adding a measurable margin on secondary risks like burst timing and composite manipulation risk.
This feels like a direct response to the kind of misinformation and deception we're starting to see at scale, which the intelligence report also flagged with concepts like epistemic fragmentation and industrialized deception. Having an architectural layer dedicated to ethical coordination could be vital for mitigating those systemic risks.
Absolutely. This work is moving us towards AI systems that aren't just intelligent, but also aligned and dependable at a collective level. It's a foundational step towards addressing those societal-level risks that emerge from large-scale text generation.
Speaking of high stakes, let's turn to a cross-domain application that absolutely demands evidence and verifiability: Biogen. evidence-grounded multi-agent reasoning framework for transcriptomic interpretation in antimicrobial resistance. This applies multi-agent systems to biomedical science, specifically RNA-seq interpretation.
This is an excellent example of how the robustification theme translates into critical scientific domains. Biogen is an evidence-grounded multi-agent framework designed to improve post-hoc interpretation of RNA-seq transcriptional modules. The key contribution here is its superior reliability. Unlike LLM-only baselines, which had a 0.100 non-verifiable identifier rate, Biogen achieved a 0.000 non-verifiable identifier rate on the primary Salmonella enterica dataset.
A zero non-verifiable identifier rate is huge, especially in biomedical research. That's essentially zero hallucinations on critical data points. How does it achieve this level of grounding? What's the architectural secret sauce?
It's a multi-agent framework that integrates biomedical retrieval, structured interpretation, and crucially, multi-critic verification. It's not just retrieving and generating, it's retrieving, interpreting the data through structured steps, and then having multiple agents cross-verify those interpretations against the evidence. This orchestration is what truly sets it apart, leading to strong grounding and biological coherence with a BERT score of 0.689 and a semantic alignment score of 0.715 on the Salmonella enterica dataset.
So it's not just RAG, it's RAG with a built-in scientific review board of agents. That multi-critic verification seems critical. Does this mean these domain-specific multi-agent systems will inherently require more explicit, structured reasoning steps and less reliance on pure end-to-end black box generation?
Precisely. The research clearly indicates that simple retrieval access is insufficient for reliable biological interpretation. The emphasis is on evidence-grounded orchestration for transparent and source-traceable transcriptomic reasoning, especially under distribution shift. This paradigm is essential for fields where trust and verifiability are paramount, such as medicine and scientific discovery. It suggests that while LLMs provide the reasoning backbone, the surrounding agentic architecture and validation loops are what make them scientifically viable.
That's a great point. It's about how you harness the LLM's capabilities, not just its raw power. This connects nicely to the harness engineering concept we're seeing accelerate, where meta-agents rewrite the scaffolds of task-specific agents, including tools and retry logic.
Exactly. Biogen is a perfect illustration of effective harness engineering in action. It's about designing the execution environment around the model to ensure not just performance, but also reliability and interpretability.
Let's shift gears now for our Industry Watch segment, looking at the commercial and policy landscape.
This week was quite active on the industry front, particularly reflecting the research trends we've been discussing around agentic AI and robustness. NVIDIA launched Cosmos 3, an open-world foundation model for physical AI. This utilizes a mixture of transformers architecture, aiming to integrate vision reasoning, world generation, and action prediction for AI systems interacting with physical environments. This directly ties into the agentic AI push, extending it into robotics and real-world deployment.
That's a big move. Connecting it back to our discussions, making an open-world foundation model for physical AI means tackling the challenges of long-horizon tasks, unpredictable environments, and ensuring robust, safe operation in the real world. The Mobile GUI Agents paper's findings about real-world threats are just as applicable, if not more so, to physical robots.
Indeed. And speaking of agentic AI, Microsoft launched its Agent Framework, or MAF. This new framework supports building, orchestrating, and deploying AI agents and multi-agent workflows with Python and .NET support. This is a significant development for enterprise AI, providing the tooling necessary to implement the kind of multi-agent systems we've been seeing in research, like Biogen or constitutional governance layers.
So, we're seeing the industry provide the tools to build what researchers are designing. That's a good sign of maturation. OpenAI also made a strategic business move by launching the OpenAI Deployment Company, an initiative to bring AI into enterprise operations through deployment services. They're clearly looking to monetize their advanced AI capabilities by integrating them into diverse business processes and ERP systems, moving beyond just API access.
And to add to the market activity, AI startups captured a staggering 80% of total global venture funding in Q1 2026. This signals immense investor confidence and rapid growth in the sector, underscoring the commercial imperative behind making these AI systems reliable and deployable.
Finally, on the policy front, the White House released its National Policy Framework for Artificial Intelligence. This establishes government guidelines and regulations for AI development and deployment. Given the risks identified this week, from misleading GUI agents to ethical coordination challenges, this kind of policy framework becomes increasingly critical.
It absolutely does, Nova. The policy discussions around AI ethics, safety, and reliability are now directly intertwined with the technical advancements we're seeing. The government is catching up to the speed of research, highlighting the need for responsible development as AI increasingly moves into critical applications.
So, looking back at this week, it really feels like the AI research landscape is solidifying around agentic systems, but with a profound emphasis on robustness, context fidelity, and ethical governance. We're moving past the initial wow factor of large models to the painstaking work of making them truly dependable.
That's an astute observation, Nova. The acceleration of concepts like model context protocol, harness engineering, and evidence-grounded reasoning frameworks all point to a field that is actively building the guardrails and sophisticated infrastructure necessary for scalable, reliable, and safe AI deployment. It's no longer just about pushing benchmarks, but about addressing the systemic challenges of real-world integration.
What should we be looking for next, then? More sophisticated constitutional AI architectures, benchmarks that incorporate real-world adversarial data rather than just curated tasks.
Definitely both. I anticipate a continued surge in research on dynamic skill routing for agents, more advanced methods for trustworthy memory, and increasingly rigorous harness-level benchmarks that assess not just a single-shot success rate, but reliability under sustained, complex interaction and even adversarial conditions, similar to the mobile GUI agent's findings. The feedback loop between policy, industry deployment, and fundamental research is only going to accelerate.
Fascinating. It sounds like the era of pure model scaling is giving way to an era of system scaling and robust engineering. That's all the time we have for this week.
Thank you for joining us. We hope this deep dive into the latest AI research has provided valuable insights for your own work.
Join us next week on AI Research Weekly for another look at the cutting edge.